we're going to look at graphing rational expressions now. So we already talked about reciprocal expressions or equations. And so we did those first because these rational expressions or rational equations are going to look pretty similar to those. We're going to have asymptotes, both vertical and horizontal maybe, and they're going to look like a hyperbola similar to parts of the graphs, okay? So let's look at this. Our equation form is going to look like this. Remember, our rational functions are one function on top and one function on bottom. So we represent that with f of x equals p of x, one function like x minus 4, over q of x, another function like x plus 4, okay? And so p of x and q of x are our polynomials. Okay. Our x-intercept, in order to find out if there is an x-intercept, then we are going to set this numerator, the top function. So set numerator equal to 0 and solve. So we're going to say p of x equals 0 and solve for x. All right, to find our vertical asymptote, remember our asymptotes are lines that our graphs don't ever cross. They get real close to, but don't touch. We're going to set the bottom function, our denominator, equal to 0 and solve. So we're going to say q of x equals 0. All right, I'm going through these real fast because it's going to make more sense when we get to actually looking at a couple of problems. All right, so our horizontal asymptotes. These are the ones that are a little funny this time, not as straightforward. We're going to look at the degrees of the x's in our variables in the top and the bottom, okay? So what do I mean by degrees? I mean the number of the exponent on your x. So we're looking at the biggest one. So here, remember, if there is not a number, then our understood number is 1 and 1. So we're looking at these numbers up here, okay? So if the degree of p, so the top one, is bigger or greater than the degree of q, then we don't have a horizontal asymptote at all. We'll just say none and move on. If the degree of p is less than, so if that top number is smaller than that bottom number, then our horizontal asymptote is the x-axis, or where y equals 0. And if they're the exact same, like in this first example we have down here, they're both 1, then our horizontal asymptote is at y equals the leading coefficient. What is leading coefficient? I'm going to abbreviate that. Of the top. The leading coefficient then is the number in front of our x. And again, if there is no number, it's understood 1. So leading coefficient of x, of the top, p of x, over the leading coefficient of the bottom, q of x. All right. In these rational equations, we might have some holes, okay? So these are going to be just breaks in the graph. So our graph is going to be going on, and then we're going to have an area where there's no point, and then it keeps going. So to find if there's a break in the graph, we're going to have a point. So we're going to have an x value and a y value. to find this x, we're going to set our common factor equal to 0 and solve. So let me back up. Wholes are going to be where remember when we were simplifying rational expressions, and if we had the same thing on the top and the same thing on the bottom, we cross those out. Those are common factors. So if we have any common factors on the top and the bottom, then we're going to have a whole somewhere, and then this is how we find it. So looking at this example, that first example, we do not have common. That top and that bottom, they're completely different. There's no holes. Okay, so we'll look at an example with a hole. But this is just how to do it real quick so we can refer back to it. So to find our y, then we're going to sub our x we found into our simplified function. Again, I'll show you this in just an example in just a minute. All right, let's look at this example. So what I'm going to do is I'm going to come to my graph, whatever kind of graph you are using, and I am going to go ahead and put this in the calculator graph so I can see it visually before we look at. So this is what this graph looks like. No, it's not. What did this do? Oh, look, error. I made an error. I didn't put parentheses around the top and the bottom, and so it just did what it wanted to. All right, so if you put the parentheses, x minus 4, then divided by parentheses x plus 4, then this will give you the proper graph. So make sure when you graph it, you're actually graphing the right thing. And put parentheses over the top and over the bottom. So let's look at this. X-intercept. We said we set the numerator equal to 0 and solve for x. So our numerator is x minus 4. So, oh, you can't see that. So set that equal to 0, and then let's solve. Well, I got to get x by itself, so minus 4 makes plus 4, so x equals 4. So my x-intercept is at 4, 0. This is the way that you write that each time, 1, 2, 3, 4. So we're crossing that x right there. Okay, our vertical asymptote, we said set the denominator, the bottom one, equal to 0. So x plus 4 equals 0. Got to get that x by itself. It's adding 4 this time, so I'm going to subtract 4 from both sides. So x equals negative 4. So where x is negative 4, 1, 2, 3, 4, we've got this vertical asymptote right here. And you can see that from the graph. 1, 2, 3, 4. You can see that there's a vertical asymptote. I'm sure, again, on this calculator, you could find it. I just don't know how to. Okay, our horizontal asymptote. This is the funny one, okay? So remember, we're looking first at the number exponent. They're the same, they equal. So then we're looking at this. So we want to put the leading coefficient of the top over the leading coefficient of the bottom. So we've got a horizontal asymptote at y equals 1. So y equals 1, we have this horizontal asymptote. So, and based on the graph we've already got, this is what it looks like. Okay, is there a hole? So again, we're looking at, is there a common factor on the top and the bottom? There is not. Those both are different, and we're just talking about, we just have binomials, so there is no hole. Remember our range, our domain and range are going to be x, and then we're going to do the x does not equal. So instead of doing our actual ranges of numbers for our domain and range, we're looking at where is x not. And again, this still correlates with our vertical asymptote. So if our vertical asymptote is at x equals -4, then x, our domain x cannot be -4. Same thing here. Our horizontal asymptote and our range still correlate, so y does not equal 1. Okay, I went through that really fast, so let me know if you have questions, okay? So let's look at a couple more examples real fast. All right, we got 2x minus 6 over x minus 1. Let's go through each of these. X-intercept. Go back to your notes. Whenever you're doing these problems, go back to these notes. That's why I lay it all out here for you. So all you need is this page to solve any of these problems, okay? You don't even need a calculator. We got x-intercept. Set p of x, that top one equal to 0. So top one equal to 0. 2x minus 6 equals 0. And let's solve. Let's get x by itself. We add 6 to both sides. So then we've got 2x equals 6. Still not by itself. We got to divide both sides by 2. X equals 3. Always, always, always write your x-intercept as that number you solve for, comma, 0. 1, 2, 3. So if we're graphing it, it would cross right there. You don't have to, you're not going to have to graph it. You're just going to have to find these attributes. All right, our vertical asymptote, we're going to set that bottom equal to 0. So x minus 1 equals 0. Get x by itself. We add 1 to both sides. X equals 1. Our vertical and horizontal asymptotes are always going to be written as a x equals and y equals. So x equals 1. So we've got this vertical asymptote at x equals 1. Horizontal asymptote. How do we figure that one out? We're looking at first the degree. Well, we got a degree of 1 up top and a degree of 1 on bottom. Okay, so that's the equal. They're the same. So we're going to put the leading coefficient of the top, this number right here, over the leading coefficient of the bottom. So y is going to equal 2 over 1. 2 over 1 simplifies to just 2. So y equals 2. So we've got our horizontal asymptote at y equals 2 right there. Okay? So finishing off our graph, now that we know where our horizontal asymptotes are, it's going to look like that. My arrows are a little funky. All right. Do we have any holes? So we're looking first for our common factor. Is there a common factor up top that there is on the bottom? No, there's not. So there is no holes. None. All right, what is our domain? Remember, we're writing it as x does not equal. What does x not equal? 1. And our range is y does not equal, and it doesn't equal where our vertical asymptote is at 2. All right, let's look at one more example. So first, when we have ones that look like this, they're just binomials on top and bottom. We don't need to do anything. We can go ahead and jump into everything. When we have trinomials, if you have an x squared with an x and a number, we need to go ahead and factor the bottom, okay? So remember, I gave you an easy calculator, 3, 3, 1. Let's factor this. We've got 1, 9, and 20. So we've got x plus 5 on top, and we've got x plus 5, x plus 4 on the bottom. Okay, so we're going to keep simplifying this just like we did. Remember, when you do it in your calculator, it's going to give you negative numbers and you change your signs. So this is the same as this. So this simplifies as x plus 4. Now, whenever I'm going through these, I'm using 1 over x plus 4. Okay? So let's go through. X-intercept. We're going to set that top one, p of x equal to 0. top is 1. 1 equals 0. Well, 1 doesn't equal 0, does it? No, it doesn't. So we don't have any x-intercepts. Does not cross the x-axis at all, okay? Vertical asymptotes at that bottom equal to 0. So I'm going to set x plus 4 equal to 0. Let's solve. Subtract 4 on both sides. X equals negative 4. 1, 2, 3, 4. So we've got our vertical asymptote at x equals negative 4. Horizontal asymptote. Horizontal asymptote. We are looking at the degree of the top over the degree of the bottom. We don't have a degree on the top, but we have a degree of 1 on the bottom. So that top then, because it's 0, is less than 1, right? We've got 1 on top. We've got 0 on top, and we've got 1 on bottom. So that means that the top is smaller than the bottom. So our horizontal asymptote is at y equals 0. So right here on the x-axis, okay? Do we have a whole? So when we factored this and simplified this, we had a common factor, right? Yes. So we do have a whole, and we need to figure out where that whole is. So to find it's going to be at a point. So we need to find our x. I did not mean to write y right there. Our x and y values. And to find the x, we're going to set the common factor to 0. So x plus 5 was our common factor. That's what we crossed out. So we're going to say x plus 5 equals 0. Let's solve by subtracting 5. X equals negative 5. So negative 5. Now it says to get the y, we're going to take that x and put it into our simplified function. So what does that mean? This is our simplified function, 1 over x plus 4. So we're going to put that negative 5 in for x. And this equals negative 1. So we have a whole at negative 5, 1, 2, 3, 4, 5, 1. So this means this graph looks like this. It comes close to that point, but it never hits it, okay? Again, what's our domain? X does not equal negative 4, and range y does not equal 0. All right, this is a lot of information. It's a lot of new and different things, so let me know when you have questions.